A block of mass 1 kg slides down a curved track which forms one quadrant of a circle of radius 1 meter as shown. The speed of the block at the bottom of the track is 2 meters per second and there is friction. So, what is the work done by the force of friction? What is the work done by the force of friction? So, this is basically you have to conserve mechanical energy, but friction is there, which is a non conservative force. So, you have to also realize that if somebody is losing energy, then that is utilized, part of it is utilized to overcome friction, and rest of it is going into the kinetic energy. So here m, when it is coming from this point, it is from this point to this point, it is losing potential energy and gaining kinetic energy, but whatever amount it is losing, a part of it will go to overcome the friction, rest will remain with the kinetic energy with the mass, correct? So yeah, so think of it now. So can you tell me how much is the potential energy lost by m, Avina?
Yes, yes, sir.
Let, considering m as the mass, what is the potential energy lost by m? How much potential energy is lost by m in reaching this place? What is the change in potential energy from this point to this point? That's
Would it be zero, sir?
why
Because it's starting from rest and ending at rest.
it's not ending at rest. It has nothing to do
Okay.
with rest, by the way. It is everything to do with height.
Hmm.
First of all, it is not at rest. Have you read the question? A block of mass 1 kg slides down a curved track which forms one quadrant of a circle of radius 1 meter. The speed of the block at the bottom of the track is given. So it has a speed here. It is
Yes.
not at rest. So what is the work done by the force of friction? This is the question.
Hmm.
My hint is whatever potential energy it loses, that is gained by the mass as kinetic energy, and some of it is used for overcoming the friction. That is the work done by the friction.
Hmm.
So how much potential energy it is losing? What is the formula of potential energy change if it is moving in a vertical level? Horrible, man. It's mgh, and it does not depend on the path. I have, for 2 days I have shown you it like this, that it does not depend on the path.
Yes, sir.
You guys are not studying, man. मस्ती करने आते हो तुम लोग. खैर, कोई बात नहीं. It's your life, your problem. Who gives a damn about it? So mgh भाई इसका potential energy loss है. So that will be equals to m, which is 1 kg, into g, which is 10, and height is 1 meter. So 1 into 10 into 1, that is 10 joules. Now its velocity is given, so I know the kinetic energy here. Kinetic energy at the bottom point is half m v square, that is half into 1 into 2 square, that is 4, which is 2 joules. So from this point to this point it came down, it lost 10 joules, but it gained 2 joules. It lost 10 joules in potential energy but gained 2 joules in kinetic energy. तो बाकी के 8 joules कहाँ गए? So you have 10 joules is equals to 2 joules plus work done by friction. So work done by friction will be 8 joules. Okay. Now whether it is, we have two options, plus 8 and minus 8. Can you tell me whether it will be plus 8 or minus 8?
So would it be minus 8 joules?
It should be minus 8 because at any moment frictional work done, friction is always opposing the motion. So this side is friction and this side is movement. So it is always negative. So minus 8. Great. Hmm. Let's try this sum. Okay. Read it. A block of mass m is released from a height r on the frictionless incline. There is no friction here. The incline leads to a circle of radius r by 2. So this height and this height should be same because r by 2 plus r by 2 r, this is also r. Correct?
Yes.
The maximum height attained by the block is what? What will be the maximum height attained by r? There is no friction here. Huh? This is a conceptual question. There is no numbers here.
So would it be equal to R?
Yeah. Just hold on a second. I'll be back. হ্যাঁ মাছ আছে মাছটাকে বার করে একটু ঝোলটা বাড়াও আলু দিয়ে পোস্ত করো আমাকে সকালে বলেছিল তুমি খেয়াল করো না। হ্যাঁ। আলু পেঁয়াজ পোস্ত করো আর ঝোলটা বাড়াও আর বৌদিকে জিজ্ঞেস করো। Correct. This will be equal to r because why? Whatever it brings down here comes into a kinetic energy format. Now whatever it has a kinetic energy format, it will go here and it will become a potential energy. So your net change in potential energy is r to r, so everything will go to potential energy. Hmm. Let's go to these guys now. We weren't doing enough. Yeah, so this is the one which was there. uh, Okay, now let's do some power based problems. So, an engine develops 10 kilowatt of power. What is power, by the way? Power is equals to dk dt or dw dt, rate of work done or rate of change in kinetic energy. So, the an engine develops a 10 kilowatt power. Unit is watt. Okay? And typically it is joules per second, which is also called watt. So, how much time will it take to lift a mass of 200 kg to a height of 40 meters? A 200 kg has to be lifted to a height of 40 meters. How much time will it take? So, if an object is lifted by a height h, what is the work done? That is equals to, whatever is your change in potential energy, it's minus of work done, but it's still the value is that. So this is how much potential energy you are gaining. Now 200 into G, which is 10, into H, which is 40. So this is 2000 into 40 joules, correct? So this is 80,000 joules. Now suppose it takes T time to take it up. So rate of this work done is 80,000 joules by T. This should be the power of the engine, which is 10 kilowatt, 10,000. So T equals to 8 seconds. Got it?
Yes, sir.
It's very simple concept. Sometimes power gives you a lot of difficulties, but it's not very difficult. Okay. A body of mass m accelerates uniformly from rest to v1 in time t1. The function of time t, as a function of time t, the instantaneous power delivered by the body. As a function of time t, what is the instantaneous power developed by the body? Think. So, the first, by basic principle of work energy theorem, the first thing is the body accelerates uniformly from rest to v1. So your w is equals to what? Half m v1 square minus 0, because it started from rest. So this is your this. So w by t, it takes how much time? T1. So power developed is m v1 square by 2t1, correct? This is your average power that is developed. This is your average power that is developed. Now, if I say my v is equals to at, this is, I know my v equals to at, isn't it? V
Yes,
equals to u plus at. So therefore, at any typical instant, I'm saying at any typical instant. So, so at any typical instant, starting from zero, my my a is how much? You have v1 is equals to a times t1. So A is actually V1 by T1. This is what is there. So V is equals to V1 by T1 into T. Now your W at any instant. W at any instant is half into m into v square. So v1 square by t1 square into t. So if I were talk about power, it should be w by t. So this by t. This is t square. V1 square by t1 square into t square divided by t. So 1 will cut. So mv1 square by 2t1 square into t. Do we have that? No, we don't have that. Hmm. This is the only one nearest to us. Uh, Correct. So 34. Let us see the answer for 34. 34 is D. So what we the answer is this correct. The order is correct, but for me I'm getting a 2 because your work done should be half mv square. Or you can take it the other way also. Work done is ma into displacement. This is the work done, right?
Yes.
And s is equals to half a1 half into a into t square. So you can write m times v1 by t1 into half v1 by t1 into t square, which is equals to same thing, m v1 square by 2 t1 square into t square. Correct. Then dividing it by t, w by t should be my power. So this there is a 2 in it. Just by dimension we got this one correct. This is correct, but I still don't know why they haven't given a 2. I'll check that out. Let's try this.
Sir, I
Ah,
was also getting a 2 there.
yeah, there should be a 2, but maybe they are doing taking some average. I'll check it out. The constant force F is acting on a body of mass m with a constant velocity v. What is the power P exerted is how much? By the way, uh, again by formula you have uh, dw dt is equals to how much? F dot ds dt. So actually dw is nothing but f dot ds. If you divide it by t, then it is ds dt. So it becomes f dot v, power. Okay. Power will be scalar or vector? Can you tell me?
Scalar.
Scalar, because it is coming from work. So work itself is scalar. So f dot v. So you have f this, v this. So this should be f v cos theta. F v, f cos theta v. This should be my answer. Get it?
Yes. Yes, sir.
Okay, let's do it with little friction. A block of mass m slides on a track with kinetic friction coefficient mu. A man pulls the block of rope which makes an angle theta with the horizontal as shown. The block moves with constant speed v. What is the power delivered by the man? Can you tell me what is the power delivered by the man?
Um,
The power delivered by the man. It is very conceptual. It is not actually mathematical. The man is giving a power. Fine. So technically, the man is giving an energy per unit time. Correct. The man is giving power means the man is giving certain amount of energy at a certain rate. I mean, in a certain amount of time. So energy per unit time. This is what the man is giving. Now, definitely, that particular power he is giving is essentially this energy is having two things. One, it is overcoming the friction, plus it is giving this mass its kinetic energy. So the thing is, what his energy is doing, does it matter to the man? I think it doesn't.
yes,
Correct. So
yes, sir.
if he is pulling it, that force itself is your T. So it should be T V cos theta. I think this is the power that the man is giving,
Yes, sir.
isn't it? Logically. Now, yeah, this power is divided. The utility of this power is divided. One is to overcome the friction at a certain rate, and to move this mass with a certain acceleration, giving it a certain amount of kinetic energy which is increasing. So that you can say. So the answer should be D. Sorry, B. Let's check. 42. 42 should be B. 42 is B. Correct. Concept is very important. I'm telling you, the basic concept, the fundamental ideas should be very clear. Numerical abilities just develops with practice, but if your fundamental concept is not clearly developed in the beginning when you are studying the chapter, then it's a trouble. Later on you can't. You cannot undo a wrong learning. That's for sure. It's very, very, very difficult to undo a wrong learning. Okay. In which case does the potential energy decrease? Again, a conceptual question. The compressing a spring, on stretching a spring, on moving a body against gravitational force, on the rising of an air bubble in water. On the rising of an air bubble in water. So when you compress a spring, its potential energy becomes half kx square. When you stretch the spring, it becomes half kx square. When you are moving the body against a gravitational force, it becomes mgh. In all these cases, potential energy is increasing. But when you are rising of an air bubble in water, okay, yes, here what is happening, a air bubble experiences a buoyant force, so the force and the displacement are in the same direction, so work done is positive, means minus w is negative, which means my change in potential energy is negative, so it is decreasing. So 43 should be D. 43 should be D. Got it?
Yes, sir. Sir.
These are simple. Okay. A uniform chain of length L and mass M is kept on a smooth table. Fine. It is released from rest when the overhanging part was the nth fraction of the total length. Okay. Find the kinetic energy of the chain as it completely slips off the table. Nice question. You should do it now. So there is a table in which there is a chain such that of the entire length, this is L by N. Okay, this is
Yes.
L by N. Now the question is, what will be the kinetic energy of this chain when the whole of it leaves the table? When it completely slips off the table, what will be the kinetic energy of the chain? This is nothing but geometry. Let me see if you can. This is this is common sense, intelligence, nothing more. Try for 2 minutes, then I'll put my hands. Yeah. Think about the change in the position of the center of mass. For the first case, divide it into two parts. See, shall I help you?
Yes.
For this part, your is this height L by 2n, isn't it? So when this whole thing is coming down, so you see this end is in fact L by 2n from the lower end. So when from this point if you calculate it, how much it has gone down from the top of the thing, it was L by 2n down. Now from the bottom, which is L distance from this, it is L by 2n upward. So this is the change in the center of mass of this hanging portion, which is up to this. Correct? And what is the change for this guy? Now this length, understand this length, this is L minus L by N, which is N minus 1 by N into L, this length. So this end will be N minus 1 by 2N into L. Now when this comes down straight from this length, it should be this much length downwards the center. So the H, so whatever this is, uh, say this part is M1 and this hanging part is M2, such that M1 plus M2 is equals to total mass of the chain. We will get M1 and M2 because we know the lengths. Now for the M1 part, the loss of potential energy is M1 into G into N minus 1 by 2N into L, because it came from this point to this point, which is equal to this length. Sorry, this point which is equals to this length. Do you get it? Because this point will now be here. So this whole thing has come down from here to here. This is the change in height. And the change in height for M2 is how much? Think about it. It was here. So this is, and now it is here. So now it is L minus L minus L minus L by 2N. But initially it was L by 2N already downwards. So what is this distance? This distance is L by 2N, L by 2N. So L minus L by 2N minus L by 2N, which is L minus L by N. This is the loss for change in height for the smaller portion. So M2 into L into 1 minus 1 by N into G. So this is the net loss of potential energy. Now how much is M1? M1 is this part, is total M by total L into N minus 1 by N minus 1 by N into L. So L cuts, this is the thing. So this is N minus 1 by N into M. This is your M1. How much is M2? M2 is M by L into whatever, L by N. So M by N. So now you see what is your total loss in potential energy, delta U. Loss in potential energy is N minus 1 by N into M into G into N minus 1 by 2N into L. So this is mgl into N minus 1 by N square, and this 2 you bring outside. Correct? N minus 1 by N square plus outside. Plus about M2. M2 is M by N into G into L into 1 minus 1 by N. So this is equals to mgl, and now you see what it is coming. It is coming. This is in fact N minus 1 by N, N minus 1 by N into just one N, so N square. So this is your total change in potential energy. So this can be taken as mgl into N minus 1 by N square. I am taking common. So what I am left over is 1 N minus 1 divided by this 2 plus 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 This one you have taken fully. mgl n minus 1 by 2 plus 1. So this is nothing but mgl by n square into n minus 1 into, this is n by 2 minus half plus 1. So plus half. So n plus 1 in fact by 2. So you have mgl by 2 n square into n square minus 1. Now this total loss in potential energy should be the total gain in kinetic energy for this one. That's what the question was. Find the kinetic energy of the chain as it completely slips off the table. So initially it was rest. So this should be the kinetic energy. So delta K should be this what? K2 minus 0, which means K2 is equals to this. So this is mgl by 2 into 1 minus 1 by n square. This is what I am getting. Let me see if we have this option. I don't think they have this option. What is the nth square gone? Okay. We might have made some mistake somewhere. So this one is L 1 minus 1 by n. L minus L by n. So this should be L minus, this is equals to L into 1 minus 1 by n by 2, this part. So this is the one, this one comes down. While this part is coming down by how much? It was this much down. Now this whole thing is here. So this height comes down by mm, you can take this as the center of mass. So this is L minus n L by 2n, and earlier it was L by 2n. So this height is L minus L by 2n minus L by 2n. So that is L minus L by n. So L into 1 minus 1 by n. Correct. So this is here. This much is coming down for the first part. This much is coming down for the second part. Now if we do that, we have m by L into, what is this part? This is my this part into G into L by 2 1 minus 1 by n. So mgl by 2 1 minus 1 by n square. For this guy, this is m by L into L by n. So m by n. Correct. M by n will be this. M by n. Correct. Into G into this one, right? L 1 minus 1 by n. So mgl 1 minus 1 by n into How much they are making? Oh no. This is such Do you see any further change in potential energy here? 56. Exactly. What is the sum number? 45. Sorry. Oh, 45. So n by 12. Oh. It is the nth fraction of the total length. It is not L by n. It is n times L. Ah, that's why everything gone wrong. So what they are saying is this is not L by n. This is n times L, nth fraction of this length. Nth fraction of the total length. So let's not waste this. Let's write it here. So our logic is correct, just the calculation was not correct. This is the one case and this is the other case. So what they are saying is this length is NL. So this length is L minus NL. Correct. Now we are correct. So this guy is NL by 2 and this full length is L. So this length is again NL by 2. So the loss in height of this part is how much? L minus NL by 2 minus NL by 2. L minus NL. So L 1 minus N. Okay. And this guy is already L times 1 minus N by 2. So this length will be L into 1 minus N by 2, which is what this thing is all about. So when this comes down. So this is the overall height that is coming down. So you have M1 into G into L 1 minus N by 2. So there is no more N in the bottom, plus M2 G into L into 1 minus N. Now M1 will be capital M by total length into this component L into 1 minus N, GL 1 minus N by 2. So L cuts 1 minus N by 2 this, plus M2 is M by L into NL. So this L cuts into G into L into 1 minus N. So this is your change in potential energy. which will be gained as kinetic energy. So you have mgl by 2 into 1 minus n square plus mgl into n into 1 minus n. This is what I'm getting. This time it will be n into 1 minus n. So you have mgl 1 minus n common, 1 minus n by 2 plus n, which is equals to mgl 1 minus n into how much? This is 1 plus n, right? Divided by 2. So mgl by 2 into 1 minus n square. Do we have this option?
Yes, sir.
mgl by 2 1 minus n square. Let's check the answer now. 45a. So 45 should be. So that is also critical. How do you read it? How do you read the story? So do you get it? What was the process and how to do it?
Yes, sir.
Should we check that also when I've got the solution? This was 34. Power is mass force into velocity ma into at. So ma square t. Hey Baba. Hmm. Okay. How stupid. Chalo, let's try one of these people. A simple pendulum is oscillating with an angular amplitude of 60 degree. If the mass of the bob is 50 gram, the tension in the string at the mean position is how much? This you should be able to do. This is very, 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 very easy. So see, these are the kind of problems which will involve you for some time. I mean, the one we just did, this one, this chain thing. Okay. So here, sorry, this one. So here what it is saying is a simple pendulum is there such that it is oscillating at 60 degree, correct? Amplitude of
Yes.
60 degree. So this is 60 degree. Now the mass m is 50 grams. So this is equals to 50 by 1000 kg. So it's like 1 by 20 kg. Okay. Now the question is, what is the tension in the string in the mean position? So say it is coming from this side. So at this point, it has a velocity, and at the extreme points, these are at rest, means velocity is zero. Correct? If the length is L, then what is the height difference? Can you tell me? This is L, this whole thing, O, A. Say this point is A. OA is L, say this is A dashed. So this point is also L, this is also L. So the height difference from this to this point is L minus L cos theta, cos 60. See, do you understand this or not? First tell me. I mean OP is equals to OA dashed cos of 60 degree. OP, O to P, and O to A is L. So L, and this is L cos 60. So the height is height that it has come down, this height. That is L 1 minus cos 60.
Yes, sir.
So MGH means L 1 minus cos 60 should be half mv square, the velocity. Correct?
Yes, sir.
So I can say that now at this point, if it has a velocity, so say there is tension T here, so this should be is equals to mg plus m v square by L, the centrifugal force. So my first target is to calculate my centrifugal force. So mv square by L will be, I just bring this L here. So what will be 2 mg 1 minus cos 60 degree, isn't it? So now
Yes,
you
sir.
see, you anyway get something in force mg into something. The cos 60 is 1 by 2. 1 minus 1 by 2 is 1 by 2. 1 by 2 into 2 is 2, 1. So this is equals to mg. Got it?
Yes, sir. Yes, sir.
So actually you have your tension should be is equals to mg plus this is also equal to mg. So 2 mg. This should be my answer. Now 2 mg is 2 into 1 by 20 into 10. So 2, 10, 10, 10, that is 1 Newton. Perfect. 53 should be B. 53 is B. Ha. Do you get it?
Yes, sir. Sir.
Great. So now you understand. This is all that is there. You just have to conserve the energies and play with it. See, we used circular motion, centrifugal force, tension, conservation of energy, everything. So actually, when you have energy in your hands, many things become very easy to operate. But that whole thing is when you will be able to exploit that only and only when if you practice, boss. So practice. The next class is Wednesday. Wednesday and Friday we are going to do lot of good sums, high level sums. See, I cannot